My name is John Basil. I'm mill superintendent here at Sonora Mining Corporation's Jamestown mine, which is located in Northern California. The mine ceased operations July 12th of 1994. What we would like to do with this video is give you a quick overview of the process, plus a good description of our mothballing procedures. This plant was a gold flotation operation. The facility is suitable for any type of selective flotation or a lead zinc copper float. We'll be starting out reviewing the equipment at the primary crusher area, and we're going to follow the flow and give you a good insight into what types of procedures we took to preserve all the equipment. Our crusher is a bird's burrow. It's a 42 by 48 inch with a dual toggle system. We've got an automatic lubrication system, which is a Lincoln, and we've got a Nyco hydrostroke feeder, which feeds the material directly into the jaw. I would like to introduce the maintenance superintendent, Ed Eversole. Ed, come on over here. What Ed and I are going to be doing now is taking you through all of the equipment. You will notice that there will be some video showing the process operating, and then we will be taking you through the plant, showing you what we've done since we ceased operations July 12th of 1994.
Okay, this piece of equipment has water-cooled bearings and the pitman on it. They were drained completely of water, and the bearings are a grease lubricated bearings, babbited bearings. We injected all the cavities with grease to purge out any of the old grease and moisture that might have been in there, and also to seal the dust out of it. And these drive belts on this piece of equipment, they were loosened up to take the pressure off of the bearings on the motor and also on the main shaft of the crusher.
Well, what you're viewing now is conveyor number 1, which takes the primary crusher material and transports it into our secondary crushing facility. As you will notice, we've got dust scrubbers. We've got 5 of them. They're Ducon scrubbers. And our next stop will be inside the secondary crushing building. We are now in the secondary crushing facility, and what you're looking at right now is one of 3 Tyler tie rock vibrating screen decks. They're double deckers, and this particular one is feeding our standard cone crusher. We've got 2 7-foot cone crushers in this facility. We're crushing down to about 2.5 inch on the standard cone, and down to about 3/4 inch on our short head cone. The standard cone crusher is equipped with clearing jacks, and both the standard and short head cone are also equipped with the hydraulic take-up systems. We've got a 450 horsepower motor on the standard cone crusher, 100 horsepower motor on our short head cone crusher. Both of these crushers are Simon Norbergs, and they're in excellent shape.
And in the secondary building, we have the screen deck, which all the drive belts were loosened up on. All the bearing cavities were purged with grease and sealed. We disconnected all of the piping to the bearings. And then on the standard cone crushers, we dismantled the crusher itself, pulled the water jacket out of it, which is the dust sealing ring, cleaned it all up, sprayed it with a rust inhibitor to prevent it from rusting, and rust inhibitor was added to the lubricating systems on both cones. Prior to shutdown, the drive belts were all loosened up on all this equipment. The spare main shafts for the short head and standard were coated with rust inhibitors so they wouldn't rust.
The secondary crusher is equipped with a ASCO 25-ton overhead crane. We can access virtually all of the equipment with this crane. It's really helpful for preventative maintenance. Down below you can see some spare parts, clamping rings. Here we have more spare parts for the cone crushers. We are now looking at the lubrication systems for both of our cone crushers. And they haven't, they've ran very well. We haven't had any problems with them. Okay, now what we're looking at is the remaining two Tyler screen decks. These particular ones are 8x16s, and they have 30 horsepower motors on them. And we have Farvel automatic loop systems for all three screen decks. We're in the motor control center for the primary crusher and the secondary crusher. We've got all the switch gear for all the components located in this room. Located in this room is Westinghouse controls. It's well maintained, and we have very good crusher availability. As the material leaves the crushing facilities, it reports to the fine ore bins. These bins hold approximately 6,000 ton each. Live capacity is about 4,500 to 5,000 ton each. Up above the fine ore bins, we've got a tripper facility which is automatically controlled to maintain the same bin level in both bins. As you can see, we have quite a conveyor configuration here. We have a closed circuit as it leaves the short head cone crusher. It drops onto screen deck 2, which you've just seen. We make a split there. The coarse material is reconveyed back into the secondary crushing facility, and the short head cone crusher is fed by a variable speed conveyor, and we average about 300 ton per hour in our short head cone crusher. As I mentioned before, we're crushing down to -3/4 inch, and our crushing time averages about 16 hours a day. Our throughput is currently averaging about 7,000 ton per day. Crusher fabrication room. We've got various pieces of equipment in here that the guys use to maintain the equipment, drill presses, all kinds of good stuff. What we're looking at here is some of the spare parts that we have on site. We've got a lot of troughing idlers, and we've got spare pitmans and shafts for the Birdsboro crusher. We've got some conveyor belting, and we've got gear reducers and all kinds of tail pulleys and take-up pulleys in this yard. We're now at the bottom of the fine ore bins. The material is metered out of the fine ore bins via 4 variable speed conveyors. The control room has the availability to ratio whatever kind of feed rate he wants to come out of any particular bin. This can be helpful if we're running a combination of oxide ore and sulfides. Currently we're running about 275 ton per hour. We have ran as high as 350 ton per hour. The material is deposited onto conveyor number 6, which has a wattometer, and that material discharges directly into our rod mill. And what we have here are we've got 4 mills, and they're hardened Koppers mills. And they're in excellent shape. The ball mills are rubber lined, and our rod mill has got Minneapolis Electric steel liners. The mill is 13 foot by 19 and a half. It's powered by a 1500 horse GE motor. We're running a 4-inch Armco grinding rods in it. We're running about a 32% charge. As I mentioned before, we're currently running 275 ton per hour, and the grinding efficiency is very good. The way that we charge these rods is we've got a charger where we place the rods in them, and an electric motor shoots the rods into the mill while we're shut down. It takes us about 5 minutes to charge the mill. Our ball mills are 14 by 23 and a half foot, and they're powered with 2,500 horsepower motors. We're currently running 2-inch steel in these mills. We're carrying about a 35% charge, and we're grinding down to approximately 10 to 15% on the plus 100 screen. Our regrind mill is 11 by 18 and a half feet. We charge it with 1-inch grinding media, and we're grinding extremely fine. Our final product is approximately 10% on the plus 325. I might add that all of these mills have bronze bearings, and each mill is equipped with a Lincoln automatic gear lubricating system. Also, each unit has a Koppers lubricating system for the lift and flood flows to all the bearings. All bearings are monitored with the resistance temperature detection devices. The bearings and the gears are in excellent shape. Okay, we're in the main grinding section now since we've shut down. And after we ceased operations, the mills were well ground out. We removed all the grinding media. All the liners were removed. And that operation went very well. Ed Eversole had cradles fabricated for each mill. And I will now let Ed describe some of the mothballing procedures that they followed on all the mills.
Prior to mothballing, we added a rust inhibitor to the circulating systems on these mills to coat the inside of the bearings, journals, and pipelines on it. The mills were jacked up and installed on cradles, so there's no pressure on the main bearings of these mills here.
What you're seeing here is one of our clusters of Krebs 20-inch Cyclones. We have one cluster for each ball mill. As I mentioned before, we only run one ball mill at a time, so it gives us plenty of time to do preventative maintenance. Now we're swinging over to the regrind mill and the Cyclones there. Those are all 10-inch Krebs Cyclones. And the fine material reports to the flotation, and the coarse material, of course, goes right back in the regrind mill. What you're viewing now is our gravity circuit, which is located on the Cyclone underflow. We have 4 American Balance jigs. They're 42 by 42, and they're variable speed. We're in the grind basement, and we thought we'd give you a shot of one of the lubrication systems for the lift and the flood flow. We've improved these units. We've got now dual filters. What you're seeing there is one motor driving a low pressure pump on the right, and that supplies the flood flow, and it also supplies the oil to the opposite end of the motor there where the high pressure pump is. They're very good units. We've upgraded them, and we haven't had any problems with them. What you're looking at now are our primary Cyclone feed pumps. We've got 2 pumps per section, which makes it very convenient. These particular pumps are Ash DG95s, and their size are 14 by 16 inch. The motors are 200 horsepower motors, and they pump the material up to our 20-inch Krebs Cyclones. Viewing now are our flotation feed pumps. These pumps pump the material that is fine enough to report to flotation. Again, we have 2 pumps per operating section, and we have 2 on the other side, which are on the down mill. These particular pumps are Ash CD65s, and they're 10 by 10s, and they're powered by 100 horsepower motors each.
And all the process pumps that are oil bath bearings, we added a rust inhibitor into the bearing cavities, loosened the drive belts up, split the pump cases apart, washed them all out, and reassembled the pump cases. The bearings on the pumps, which are a greased bearing system, we purged all the bearings and seal areas to seal up those bearing cavities.
All the grinding mills are equipped with the Farwick air clutches, and they have performed very well. They're very durable pieces of equipment. Doing the overhead crane on the main grind deck, it's a P&H crane with a 25-ton hoist and an auxiliary 5-ton hoist. Very good piece of equipment. And what you're viewing now is 2 of our rougher banks. They're agitator cells. They're 500 cubic foot and equipped with 30 horsepower motors. And at the far end, we've got 2 door Oliver cells. Those are our scavengers, and those are 1350s, and they're equipped with 60 horsepower motors. Next, you'll be viewing the first cleaners. They're agitators also. There's 9 cells in this particular bank, and they're 600 cubic foot cells. They also are equipped with 30 horsepower motors. Now we'll swing over to our second cleaners, and they're agitators also. They're 400 cubic foot with 30 horsepower motors. The third cleaners, again, are agitators. They're 400 cubic footers, which we're not using currently because we've gone to column flotation. And we'll go over and take a closer look at the column. After we shut down, all the mechanisms were cleaned out, all of the bearings were purged, and all the drive belts on the motors were loosened up so there was no stress on the motor shafts. What you're viewing now is the final product coming off our Deister flotation column cell. This column cell was new in 1991. It's a 41-foot unit, and it's 48-inch diameter. And this piece of equipment has performed outstanding. This piece of equipment allows us to pull our mechanical cells very aggressively, and this unit cleans our product to very tight, rigid specifications. We're currently averaging a concentrate grade anywhere from 2 ounces per ton to 4 ounces per ton. We have obtained grades as high as 12 ounces per ton using this unit. The column cell is fully automated. The control room operator can set the perimeters for density and pulp level and maintain those without any operator work involved. This allows us to always maintain a good pulling cell, and it's helped our recovery immensely. The Bay Area is serviced with a P&H 5-ton crane And again, this unit has been very reliable and really helps us on our maintenance end of things. What you're viewing now are our Peterson drum filters. These are 10 foot by 16 foot, and they are doing a remarkable job considering how fine we're grinding. One thing that we have determined is that we have to maintain the proper solids to come up with a cake of approximately 10% moisture. And this is very, very good efficiency. This is the intermediate section of our column cell. We'll be now going down to the flotation basement where we can show you the rest of the equipment down there. In basement, and what we're looking at is the control system for the column cell, and also the tails pump, which is a Sala unit. The flotation area, and I might add also on the regrind mill, are Gallagher vertical pumps. The pumps you're looking at here are 6-inch by 72, and they've got 15 horsepower motors on them. These pumps have performed wonderfully. I myself was somewhat skeptical when I saw vertical pumps, but their performance is just impeccable. We're getting a year and a half life on wear parts on the wet end, and they've been a real positive influence on our maintenance costs. What you're looking at now is our Buffalo blower, and it's equipped with a 200 horsepower motor, and it puts out about 1160 CFM. This applies our low pressure air to our Gallagher flotation cells. We also have 2 Nash pumps for our vacuum pumps, and we have a Quincy air compressor, and also a Roots low pressure blower which supplies air to our Door Oliver cells. Old room here at the Jamestown mill. In this particular room we've got a Deister concentrating table. We do have a spare tabletop which we have kind of customized the design to increase our tonnage off these tables. We've raised the riffles, and we're currently running probably about 40 to 50 ton per day. Our collection off this table has been exceptional. Back in 1992, we collected approximately 40,000 ounces off this table. We also have various Swaco screens, which allows us to do cleanouts up in the low areas in the grinding section. We get splits that allow us to run the fine material directly on the table, and it allows us to get the coarse free gold out of the circuit. Our system's been upgraded immensely, and it's a very efficient little system. In our concentrate thickener, this particular device is a Door Oliver 75 foot. We've got the automatic rake lift device, and this allows us to maintain the desired solids that we pump up to our drum filter, which is very critical to our operation. And panning out a little bit further is our tailings thickener. It's a fixed rake 300 footer, and it's been operating very well. We are currently pumping about 50 to 55% solids up to our tailings facility. Concentrate thickener underflow area, and the pumps that we use to pump the thickened material back up to our drum filters are Ash A65s, and these are 3-inch by 4-inch, and they've got variable speed 15 horsepower motors on them. Again, we've had very good luck with extended life on wear parts, and they run very, very smooth. I thought I should mention is we've got the Texas Nuclear density control devices, which allows us to maintain very tight density controls on the material being pumped up. We're now down in the reagent area, and what you're viewing is 3 of our bulk storage tanks. The reagent building itself holds all of our mix tanks and also our chemicals that we have to mix. We'll be going inside to take a look at that section here. Reagent building, and as you can see, we've got various size mix tanks. These tanks are serviced with a monorail with a 1.5 ton hoist, which allows the operators to get the materials up on the mixing deck. Some other items that we have of interest is we have an automatic flocculant mixing system, and that's allied colloids, which allows us to save a little bit of money on our flocculant costs. We're now in the tailings thickener underflow area. We have to pump our tailings slurry in a series of pumps. The pumps that we're going to be going down to look at right now are Denver Orion. They're 8-inch by 6-inch, and they're hard metal pumps. The tailings booster pumps are GIWs, and they're 8-inch by 6-inch. They're also hard metal pumps. Denver Orion pumps are powered by 200 horsepower motors. Again, they're fixed speed pumps. In the GIW pumps, these are our booster pumps, which pump the material back up into our tailings basin. Currently, we're pumping at about 230 foot ahead, and these variable speed units allow us to keep our pressures down and still get the material placed up in the tailings facility where we want to. These units, we're currently pumping with about 180 psi, and we're getting pretty good wear life out of these pumps because we're only running them at about 55% of max. Oh, it's our process water pumps. We've got a closed circuit on all the water, and we get returned from our tailings facility. And these particular pumps are Fairbanks Morse. They're 40-foot long, 2-stage vertical pumps with 200 horsepower motors. We do have a spare unit on site, ready to drop in if we need it. Approximately 4,000 gallons, and which is more than enough for our needs in the concentrator. Tailings MCC, and what you're looking at here are the variable speed units for our booster pumps. They're provided by Reliance Electric, and again, we haven't had hardly any problems with them. The units inside has its own isolation transformer, which cleans up the act, and everything runs a whole lot better. We're now in the emergency generator room, where we have backup power supply if we have a power outage. We have 2 Detroit generators, 500 kW each, and they allow us to power up all the critical items if there is an outage. For example, our concentrate thickener, our tailings thickener, our tailings booster pumps, and various pieces of critical equipment in the concentrator itself. These units automatically kick on if the power is interrupted. They equalize themselves and allow us to, from the control room, start all the equipment that we need to start. And they have been, again, very reliable. Viewing the high voltage switchgear room back in the concentrator, this is where we have all of our buses and our switchgear for the mills. Now in the main motor control center for the concentrator, this is all Westinghouse gear. Uh, 10 rows of 25 each buckets. And part of the Swanson low voltage system. This picks up all the critical information we need from the remote controllers out in the field. And this information is transferred up to our control room. Again, it's a Swanson Monotrol control system, low voltage. We're now in the control room. The control room provides centralized control of virtually all the major crusher and concentrator equipment. The computer and the controllers are Fisher-Porter, again with a Swanson low voltage system. A communication system that is comprised of an intercom and radios and telephone enables the control room operator to gain access to virtually all the personnel that are concerned with the operation and maintenance of the concentrator. The systems are well maintained and allow for maximizing throughput as well as reducing troubleshooting time when problems occur. What you're seeing here is our programmer Dave Hobbs and our control room operator Wilbur Crackle operating the system. Our system is it's a very good system for the simple fact that we don't have too much instrumentation. Our controls are we're maximizing the computer's ability to provide us with the information we need to maintain correct flows and a smooth operating plant. I might add that this unit is a new unit in 1986. Ability to run the concentrator off the Swanson panel, which you're now viewing, if we have computer problems. One other thing that we have is a backup battery supply. If we have a power outage, these units provide life to our control systems. Again, we are currently running 6,300 ton per day. We have averaged during a 30-day period approximately 7,800 tons per day of feed through the plant. In my opinion, we have the ability to increase throughput up to approximately 9,000 ton per day with only minor design changes. A few things that we've done here at the Jamestown concentrator to improve our operation is we've given preventative maintenance a very high priority. Our availability for 1993 was 93%. We could have done actually considerably better than that. We are blessed with the ability to outperform the mine as far as tonnage goes. So we've incorporated a system whereby every Tuesday we shut down and maintain the equipment. As you noticed in viewing the grinding section, we do not have any leaking bolts. We do not have any leaking pipes. We simply do not allow that to happen here. So the equipment is in top-notch shape. Through design changes, we've allowed ourselves to improve the linings in the sumps, and hopefully those people that are involved in maintenance will appreciate a plant that they walk through and they do not see patches all over the equipment. Items that we failed to mention earlier are the complete fire protection system that we have throughout the facility. This includes all the office buildings, the primary crusher, secondary crusher, and the all critical areas in the concentrator itself. Also supported with a diesel pump, which allows us to supply water even during times of power outages. We test the unit once a week, and again, we haven't had any problems with this unit. Items of interest are staffing levels here at the Jamestown concentrator. We currently have a group of millwrights, 12, which maintain the crushing and concentrator. We have 2 supervisors in that group also. The concentrator runs 24 hours a day, 7 days a week, and we have a total group of 44 people that rotate on shifts. We're very efficient. We've tried to use our instrumentation to reduce our head count, and we've successfully dropped our head count from 90 in 1990 down to our current complete workforce, which includes the analytical and metallurgical staff, of 78. The next area that I think we need to visit would be the analytical lab. where you can see some of the equipment that we use to process all of our samples. Now in the laboratory area, and what you're viewing here are the ovens where we dry our samples. This is a brand new oven that we've had for approximately 2 years. We do approximately 6,000 to 8,000 samples per month here with a very rapid turnaround time. We will now be going into the sample prep room where we've got our jaw crusher, our pulverizers, and various ancillary equipment, including pressure dryers and things of that sort. This is where we do our metallurgical work. We've got the portable flotation mechanisms, we've got row taps, various screens. We have drum rolls for doing grinding tests. Area where we do our fire assays. We've got 2 furnaces. This is the remainder of the analytical area where we process a lot of our samples. We've got various hooded areas for containment where we do our weighing. Again, the equipment's in real good shape. David Camacho is the supervisor over the laboratory facilities and has done an excellent job. Reviewing now is our sulfur analyzer, which is very critical to the operation of the concentrator. Oftentimes we dictate our reagent consumptions and things like that based off the amount of sulfur in our feed due to our low feed grades. Atomic absorption device where we use this to come up with about 1/3 of our samples. Leaving the laboratory, we're now going up the hill a ways to our automatic fire protection system. We'll get some close-up shots of the equipment and try to describe some of it for you. It has an electric motor that provides pumped water into the system under normal conditions. And as mentioned earlier, we have a Detroit-driven pump which allows us to energize and maintain the fire suppression systems even in times of power outages. I would like to introduce Ed Bush, who is the electrical engineer in charge of all the electrical and instrumentation at the project. Ed is also in charge of all the special projects. We're going to be taking you out to Ed at the main metering station, which takes our power off the main grid. Ed? Take it.
Yeah, thank you, John. We are located here at the metering substation right now. Purpose of this substation is twofold. It provides all the metering services for our local utility company, PG&E, and it also provides protection because this is all 115 kV, and we have battery-operated switches that operate off of both manual controls and protective relays that are inside these enclosures over here. Okay, inside these enclosures are the protective relays, and they provide overcurrent protection, ground fault protection. Any time any of these relays sense disturbance in that area, what will happen is it will open up these main switches that provide power to the mine. On the metering substation here, it's fed down through this power line. The power line is approximately 8/10 of a mile, and it feeds the main substation that's located at the mine. Okay, now we're located inside the main substation, located right on the mine site, where we come into some more battery-operated Siemens Alice 115 kV switches, and those switches feed this 12.5 megawatt transformer. Feeds this set of switchgear. Now we're inside this switchgear housing. And this switchgear actually divides the power that is now 4160 up into 4 areas. We have the truck shop feeder, which also feeds the tailings area. We've got 2 feeders that feed the concentrator, and then we've got 1 feeder that feeds the crusher, because they're all battery backed up. These batteries also feed the main incoming switch. Feature ground fault protection, overcurrent, undercurrent, and phase imbalance. Quick overview, I've made up this single line diagram on exactly where our power is distributed from. Primarily we come in, as I said before, on the 115 kV line into the metering sub. Metering sub overhead is taken up and feeds a 12.5 MVA transformer that feeds the main sub. Main sub then distributes 4160 volts in 4 different directions. First place it takes off to is it goes to a crusher substation. A crusher substation has a 1200 kVA transformer that transforms the voltage down to 480 and is distributed from 480 to 120 throughout the crusher, and then it has 2 4160 feeders that feed the secondary crushers. Another feeder that comes from the main sub takes it down where it feeds into the electrical and truck shop. That is fed from a 750 kVA transformer, and that is distributed down to our 48 and 120 volt areas. From the truck shop substation, its paralleled feeder is 4160 also to the tailing sub. Tailing sub then has 2 transformers. One is a 750 kVA, the other one is 1000 kVA. That distributes down to our 48 volt feeders also. Also coming out of the tailing sub, we have 4 75 kVA transformers. They're isolation transformers that feed our Reliance variable speed drives. We have 2 feeders coming out of the main sub, 4160 volt feeders that feed 2 areas of the concentrator sub. Those 4160 feeders are broken down to 2 feeders that feed 2 mills on one sub, 2 feeders that feed 2 mills on the other sub, and we have 2 1200 kVA transformers that distribute our 480 volt, 120 volt system of the floor. Also out in the mine, we have 1 substation out there that's fed from our 17.5 kV. It has a transformer that distributes it down to 480 volt that comes out and feeds a mountain power supply.
Thank you very much, Ed, for your description of all the electrical systems. We are now out at the front entrance to the Jamestown mine. What you see here is all the mobile equipment that we've parked here in the entrance area. When the mining was completed, we sent all of the mobile fleet through our truck shop. We went through all the major components, made sure the transmissions and engines were all in top-notch shape, and then we spruced up the fleet and made it look virtually brand new. Behind me you'll see our fleet of 12 Electrohull 100-ton end dumps. These are unit rigs that have been beefed up to 120 ton. We also ran a fleet of 6 hard rock drills. The units that you're looking at here are the Tamrock Drill Techs. Again, all of this equipment was highly maintained. The maintenance people and the operators showed a lot of pride in the equipment that they operated. We utilized 2 Wabco 8,000 gallon water trucks for watering down the roads in the mine. Next you'll see a 988B push dozer in real good shape. We have a 988B front end loader. Again, it's in good shape. And we're looking at 2 Ingersoll Rand compactors. These babies are like new. We also ran 4 dozers in the pit. We'll show you our Komatsu here. It's a D355A. The mine operated with 3 Hitachi shovels. We have a matching pair of UH801s and a EX1800. We're also going to show you our excavator. It's a UH122. Our 1800 was completely rebuilt back in 1993. All of the major components are new. Again, the fleet was highly maintained right up to the end of the operation. I would just like to leave you with this, that what we have here is a highly maintained facility, a highly maintained fleet that's ready to be put back into work. Thank you very much.